The idea of equilibrium involves sameness and constancy. So a chemical system at equilibrium has the rate of the forward reaction equaling the rate of the reverse reaction. But this is not to be confused with everything being static and the same. So there is sameness and constancy, and yet things are happening. So we have rates of reaction that are the same forward and reverse. What is a rate of reaction? This measures how fast the reaction proceeds. It's often given as the amount of reactant that changes to product in a given period of time. Reaction rates can change, and they often do change. And so we need to understand some of the factors that influence the rates of reaction. What makes a reaction go faster? What makes it go slower? And if we understand those factors, then we can change the rate to suit our purposes. Yeah, I knew this morning I somehow skipped this slide, so that's too bad for them. I don't know. Anyway, this is an important slide they missed. So collision theory. Collision theory helps us to explain how reactions occur, and the idea here is that chemical reactions occur through collisions between molecules or atoms. And this makes sense. In order for two molecules to react, they have to come in contact with each other, right? If they're on separate sides of the room and they never come in contact with each other, how are they going to react? And my analogy in chemistry land is, how could you fall in love with someone if you don't even know that they exist, right? So maybe they live in Iowa and you live here in California. There are people who live in Iowa. I used to be one of them. So there are people there. How could you fall in love with them if you've never ever met them, never talked to them, don't even know that they exist? It just couldn't happen, right? So to fall in love with somebody, the first thing is you need to meet them. So we have to have a collision, and just colliding isn't enough. It has to occur with enough energy for the reaction to proceed and form the products. I think we've all probably had an experience where the first time we met someone, we just weren't impressed. But then maybe when we met that person again later, conditions were different, and now that all of a sudden they've become a friend of ours, or perhaps even someone that you fall in love with. So the collision has to happen with enough energy. If you have two molecules and they just come slowly and bump into each other, that might not be enough to make anything happen. So there has to be enough energy. The collision energy is related to particle velocity, which makes sense. If you think about two particles coming together, the amount of energy that they have when they collide relates to how fast they're moving. Well, especially when we talk about things in the gas phase, molecules have a wide distribution of velocities. Some of them are moving fast and some of them are moving slow. We talked about how temperature is a measure of the kinetic energy of a substance. And that temperature is a measure of the average kinetic energy. Well, some of the molecules may be at the average kinetic energy, but some of them are moving faster and some of them are moving slower. And if you have the slower ones colliding, they may not have enough energy to have a reaction occur, but the faster ones will. So the higher energy collisions lead to products, the low energy collisions do not. So then we can look at factors that affect this. And that collision energy has to do with an activation energy. It's a barrier that must be overcome for the reaction to proceed. A lot of times a reaction, in order for a reaction to occur, some chemical bonds have to be broken. Like in that reaction that we were, no, it's the reaction we're going to be looking at, sorry. Hydrogen reacting with iodine to form hydrogen iodide. Well, H2 is a molecule, two hydrogen atoms bonded together. And I2 is a molecule. two iodine atoms bonded together. In order for them to react and form hydrogen iodide, those bonds have to be broken. There has to be enough energy in the collision to break the old bonds before the new bonds can form. And that's called an activation energy. So if you have enough energy in your collision to overcome the activation energy, then the reaction can proceed. So the factors that are going to influence the rate of a reaction are the same factors that influence the number of high energy collisions. And there's a couple of them we're going to look at. One of them is concentration. What we find is that the reaction rate generally increases when we have an increasing concentration of reactants. So let's look at this picture. Here we've got this reaction between hydrogen and iodine, and here we have some hydrogen molecules and some iodine molecules. And so this is a low concentration. Here's a high concentration. Well, think about these molecules moving. If they're at the same temperature, then they're moving at the same average speed. Are we going to get more collisions in panel A or in panel C? In panel C, right? If you think about a room with maybe 5 people in it and you're walking around, or a room with 25 people in it and you're walking around, you're more likely to bump into people when there's more people in that same small space, right? So when the concentration is higher, then there are more collisions. So higher concentration means more collisions. That makes sense? They have to run into each other to react. As the reaction proceeds, though, the rate is going to decrease because the reactant concentrations are going to fall. As these reactants react, they form the products, these guys, and then they're no longer available as reactants. So what happens? Let's see, maybe I can draw on this. So, what color? Let's use red. So maybe these guys bumped into each other and they reacted. So they're out of the picture now because they formed product. And then these guys bump into each other and now they've formed product. They're not around anymore. These two formed a product. These two formed a product. What's happening to the concentration of the reactant? It's decreasing because it's reacting and forming product. So if you have a closed container and you put a certain amount of reactants in there, as the reaction proceeds without you doing anything, the reactant concentration goes down. So if the reactant concentration goes down, then what happens to the rate of that reaction? It goes down because there's fewer collisions. Temperature affects the rate of a reaction. We find that usually the rate increases with increasing temperature. That's because raising the temperature makes the molecules move faster. So here we have molecules moving slowly. Here we have molecules moving faster. When they're moving faster, they're going to run into each other more. So you take those 5 people in the room and you heat them up. You make them move faster. Now they're running as opposed to walking around the room. Are there going to be more collisions? Yes. That's why they tell children at school to walk in the hallways and not run, right? Because when you run, you're more likely to hit people, to bump into people. And when you do bump into people, it's a higher energy collision. So not only do we have more collisions at higher temperatures, but those collisions are higher in energy. Both of those things are going to cause the rate of the reaction to increase. That make sense? So to speed up a reaction, we can increase the concentration of the reactants, or we can increase the temperature, or we could do both. So summarizing this, reaction rate generally increases with increasing reactant concentration, with increasing temperature, and as the reaction proceeds, the reaction rate decreases because we're using up the reactants and their concentration is decreasing. So let's think about a chemical reaction between two gases. You would expect that increasing the pressure of the gas would do what to the rate? Would it make the rate go faster? Would it go slower? Or would it have no effect on the reaction rate? It would increase it. Increasing the pressure. Well, it's not a good color. Will increase the reaction rate. Why? What happens when you increase the pressure of a gas? Yeah, there's different things that can happen. It depends on if we compress a gas, oftentimes the temperature will go up, which will cause the particles to move faster. We could also think of it as taking the gas and making it smaller. We're compressing it. What does that do to the concentration of the gas particles? It concentrates them, right? They get closer together. So we anticipate that there's going to be more collisions.